Uncle Ron and stuff. Today is water heat. I can't even talk today. Water heater leaking. Another YouTube video about a leaking water heater. Please do not move on to the next one yet. Um, if you have a leaking water heater, you can probably find a lot on YouTube. And I looked at a lot of them, and everybody provides some element of information. But personally, I think the more you view, the better handle or understanding you'll have of your leak, maybe how to fix it, and how to deal with it until you can get a new one. Okay, so I've got some things that I haven't seen in any other YouTube video. Hopefully, there'll be a benefit. This could be long, but anyway, the point here is I have a leaking water heater. And uh, the real issue for me is that because it's a 75-gallon tank, I have to order it, and it's not supposed to be in for a week. So the normal YouTube videos tell you to turn off everything. Turn off the inlet water to the water heater, turn off the gas to it, and that's all fine and dandy. And you can drain some water out, and that leaves you with no leak, but no hot water. So, yeah, that's one way to handle the problem, but what do you do in the meantime until the tank that you've ordered shows up and gets installed? That's the situation I had to deal with because I need hot water. And the tank isn't going to show up here for a week. That's what they say. So, is there some way to use the system so it doesn't leak excessively in the meantime? And that was really the focus and point of what I tried to do. Now, here I'm going to first cover the generals of a hot water heater. And so you may know all this, and it's covered in a lot of the other videos in one way or the other, but it varies on the manufacturer of the water heater you have. So, and so is what I'm going to show you. But nonetheless, the idea is that once you get it, you know all about the water heater and how it functions and not supposed to function. There may be a way that you can limp along until you get a new water heater. It's not necessarily mandatory that you completely shut the thing down, have no hot water until you can get a new one installed. I know there are advertisements all over the place, 1 day installation, and that may be true, I don't know, but they're going to bring whatever water heater they have in stock. You probably have a 50-gallon water heater, that's the normal sort of small house, if you will, or a regular size house, 4 or 5 people. I have a larger home with multiple bathrooms and showers, and there was a 75-gallon tank. I thought about going to a 50, which is in stock at big box retailers, blah, blah, blah. And I probably could have had it up and running in just 2 or 3 days. But there was no 75-gallon water tank in stock at any of the big box retailers locally, and I did not check the plumbing supply people. They may have had one, but theirs are all going to be expensive. And water heaters, if you don't know, can for a 75-gallon run from like $1,500 to maybe $5,000, depending on all the bells and whistles they have. Okay, so I'm going to start off. And I'm going to do what I did before. I don't like using my iPhone as a video camera to show things, so I'm going to be holding up pictures and trying to explain the importance of each. Okay, this is a picture of my leaking water heater. It is a 75 gallons. You can see it's pretty tall. And uh, that is what I got. Okay. This piping over on this side right here is sort of special piping. This thing has a dedicated return line. There is a pump, And the idea is that it constantly circulates water in the system so that you don't have to wait 3 minutes to get hot water. It's supposed to speed that up. I find it really doesn't work very well. Perhaps my pump is too small or whatever. It's an electrically driven pump that's supposed to recirculate. I don't use it. But anyway, that's that extraneous stuff. But there is what a typical water heater looks like. And at the top, this particular one is, I think, what's called a direct vent. And that means that the exhaust gas comes up through the water heater here and then out. There's a flue right in the middle here, and it goes on out. In this case, piping goes out to the roof and out. The line over here is cold water input. The line over here is hot water output. Okay. My particular, and yours will have the same. There should be a tag on it somewhere, which shows the model number, and you can see that up over here. There's a model number, and it is a natural gas, not propane. It shows 75,000 BTU inputs, and it also shows the date of manufacture, which is right, where is it? Right there. It was manufactured in 2010, in April of 2010. It is now February 2023, 24. So it's 14, 13 years old. And if you look at any kind of information, that is supposed to be the life of a water heater. I don't really buy that. They should last longer than that. The old one I had in the previous place was already 25 years old and still going well. Okay, so this is another picture of the water heater. This is the bottom, and all will have a similar arrangement. There is a gas control valve over here. This is the yellow is the natural gas control line coming up. The other thing of note is the drain valve over here. And you can also set the temperature of the water you want by this dial. This is a on and off for the gas control valve here. There's the gas shut off line valve right here. And this is with the panel off and all these connections going to the burner. Everybody has similar things. This is what the gas line looks like. This is in the open position. This is the gas line valve right off the gas line, and you can turn it on and off to shut off all gas to the hot water heater. Looks like that. Should have a little yellow line. This shows the cold water inlet valve, which the idea being is if you have a problem like a leak, you can shut this valve off and stop water coming into the water heater, and that then will let you, if you need to, totally drain the tank of water. Now, in my particular case, this valve is no longer fully sealing. I found that out, and I'm now having to shut off all the water to the house to keep water from leaking past this valve into my tank. I don't like that. The new water heater coming in will have a brand new valve installed as part of the installation. Apparently that's a normal routine thing, and it's good for me. Here is a backflow regulator. I don't believe it's a pressure regulator. It basically says that the cold water will maybe regulate no more than 125 psi can get into this water tank, and you'll have something similar down here somewhere. Okay. The next part of the water heater, which you should be familiar with, is pressure relief valve. Pressure relief valve is right there. And the function of that is the tank is full of water. It starts getting heated. Water expands, as you know, when it's heated. It just does. So, if for whatever fault or reason, too little water in the tank, the burner does not shut off when it should. The water can get so hot in here that it actually begins to go into steam, if you will, and pressure would build up. And this particular valve is set to automatically open and release some of that pressure. This is what the valve looks like coming right out of the tank, and this lever right here is in the normally open position, normally closed position, and it will automatically open up if it needs to. But this is the arm that you can use to open up this valve. The bib here at the bottom is required to go down near the floor, so if this thing's opened, it doesn't send scalding hot water everywhere. So there is a pipe coming down off of this. Okay, on your gas regulator, on your water heater, you will have this knob at the top, and this shows currently in the full open position. That means gas can go to your burner as this device dictates. Uh, this knob rotates, sometimes has to be pressed down to rotate, but it can rotate back to the pilot position over all the way to the full off position, which is over here. This over here, I'll get it in the end, is my pilot light igniter, and it is a push button on this green thing. You push it this way, and it's supposed to create a spark. Mine does sort of randomly. It's not all the time, but then I don't shut the, the pilot light off very often. So I'll talk about that later. This shows the gas turned off at the tank regulator in the off position. You'll see there is an arrow at the top. All right. For your amazement, this is what the burner looks like inside the tank with the front cover off. It basically gas goes into the bigger pipe, which is right here. This is the big pipe coming from your gas control unit mounted on the water heater. It goes down here. It comes out a small hole. There's also a tube leading up that provides gas, which is the pilot light. This is the burner out of my particular water heater, and it doesn't show real well there. It focuses correctly. Again, you have over here. This is the main gas line. This is the pilot light gas line, and here is some details which you probably don't worry about, what the whole pilot light assembly looks like. Okay, and this part is the igniter. Here is the pilot light gas tube. A small amount of natural gas comes pouring out this port. And over here is what's called a thermocouple. And the idea is that if you want to light your pilot light, you set it to the pilot light position. Usually you have to hold down a button or something to keep the pilot light gas flowing while you hit your igniter. And spark will jump here between this end and the uh, pilot light gas tube, and it will light a flame here. And you usually have to hold down your natural gas pilot light knob or burner or button, whatever it is, until this thermocouple gets hot enough to know, yeah, we really did get ignition of the pilot light. And then you can release that, let go of the pilot light button, and you'll have a flame right here. There's a flame right there all the time, and that's your pilot light. Okay. Pilot light instructions are provided on the tank. If you ever have your pilot light go out, these instructions should be right here, tell you how to do it. Now, if you don't get a spark, you probably have a bad ignition unit, and I showed you where it was on the controller here. Also, what it looked like inside of the burner unit. So you can probably get a new igniter easily enough for your particular unit and replace it yourself. You might have to take out the burner to be able to fully do it, but nonetheless, this is a side issue to the main thing of leaking tank, but it can be done. Now, in my case, I told you my igniter is flaky, so what I'm currently doing is I use a long, if you will, match. I open up the pilot light, turn on or push down, open the pilot light line. I take my match, I put it up near the port. The pilot light ignites. I keep pushing down or allowing the automatic control to be engaged until I can release the pilot light button and the pilot light stays lit. That's what, again, the pilot light, the thermocouple there has to detect pilot light burning long enough to allow it to then control the pilot light line. Okay, this is hooked to the drain valve that you have on your tank if you want to drain the whole tank. Okay, in my case, I put a pressure meter on it because I was curious. What is the pressure inside the tank when it is fully full of water and it has reached the temperature setting I have put on the control valve mounted to the hot water heater. And I think I have it set at about 125 degrees. And you can see that this is the pressure, 70-pound PSI. From my readings, some 60 to 80 is desired. If it's above that, it's too high and you might have to take some action. If it's below that, somebody should look into why it's below that. It may be that the valve at the street is not fully turned on, or there's some other plumbing issue. Or you may not have the water inlet valve at the top feeding the system fully open. But anyway, 70 is what I got. One of the things I thought was interesting and I would pass on is this is looking into the burner cavity and with the burner removed. And what I found interesting here is right here in the cosmetic shell and all of the white material, or in my case gray, of the cosmetic shell where all this stuff is located, that's just cosmetic. It's basically sheet metal. Sheet metal. It has insulation in behind it, which then keeps the water in the tank, which is in behind all this stuff, uh, reasonably hot. So when I took the burner out, I could see that it's interesting here in the cosmetic bottom, right underneath of the burner assembly, there is a dimple. There is a concave downward. And on my particular furnace, and probably most of this type that have that kind of venting at the top, when you first fill a tank and the tank is full of cold water um, and it's humid, condensation will form on the inside of the tank and particularly around where the flue is and will drip down. And if the burner is not going, it will drip around the burner and it goes into that dimple or concave underneath the burner. So I think that's really to catch some of the condensation. In the very bottom of the cosmetic, you'll find multiple holes, or mine has multiple holes uh, in the center, and the plate that there's a plate, two plates right here, in fact, that's set over the cosmetic bottom. And again, there's the dimple. So if too much water gets in the dimple, it will come out one of these holes, or there is in fact small holes on the bottom of the cosmetic plate near the edge of the gray metal cosmetic down here at the bottom. The cosmetic sheet panel outside is just bolted at the bottom, but the pan, there is such in a pan at the bottom of cosmetic metal. And so water can accumulate along that edge, and I, in fact, have seen rust along the edge of my particular one. Condensation when it got into, it overflowed, went off and got into that edge, got soaked in the insulation. Okay. The final thing of note on the underside, I thought, was this is with the burner removed, looking upward. And what I found is my particular tank is concave shaped, and meaning that the burner sits down below here, but the tank is in fact concaved, and here is the flue, okay, where the hot gas goes up through the middle of the tank and then out the vent at the top. And my hands are, by the way, from working underneath of this thing. Okay, so in my particular case, I found water dripping out of the flue, and it wasn't condensation, or it wasn't coming in the vent at the top. If you have a problem with your venting system, rainwater or whatever, may come down that vent and drip down the flue onto your burner and then collect in that concave underneath. Okay, so I had water dripping right out of here, out of this flue thing, and it would drip down along the seams here, and it kind of dripped, it sheet water down on the edge, and then would collect along the edge of the cosmetic sheet molding, and would also collect in the middle in that condensation pan, and or eventually overflow, and that's where my leak was. Okay, so I got a leak, and I can see where it's coming from. Well, sort of. I know it's coming down the flue. Now I get to it. I will tell you later what I tried to do to look at, find out what the word exactly what the leak is. But I want to next talk about leak. The manufacturers all say, well, they have a lifespan of 10, 12 years. Okay, 15 years, whatever it is. And I always had trouble understanding, okay, the tank itself has got to be at least a half inch of sheet metal or maybe more, or somewhere in that area, or metal of some type, and then coated on the inside. And I always found it difficult to imagine that there could be rust or whatever occur that it ate a hole through that tank. And then I understood the tank is not made as a single unit. It is made as several parts and then welded. And so when the manufacturer says, well, or somebody says, well, it's leaking, it's either leaking at one of the fittings that are in the tank, such as the high pressure relief valve, or the drain valve, or the cold water inlet valve, or the hot water outlet valve. Those are logical places for it to leak because those have actually penetrated the tank. There already is a hole there. Okay. So, um, leak. I did, in fact, go ahead and shut the water off and drain the tank and replace the high pressure release valve, and I replaced the cold water, the drain valve, thinking perhaps it's leaking at those things, even though I couldn't see it, and there's a very small hole in the cosmetic shell where those pierce the tank. But that did not solve my problem, and then upon further investigation, I found it was, in fact, leaking directly down the flue. Okay, so back to the leak. Um, it's the welds that wound up leaking. Now, supposedly there's what's called an anode rod inside of all water heaters that's made out of some other material, magnesium or something. And the idea is it will attract various minerals or chemicals in the water that keep from corroding the inside of the tank. Now, um, uh, when I first open it up, and I show you right here, the flue, you can see rust. And you can see some rust along the bottom here. Rust needs air to for it to form correctly. You're not going to see rust inside. You fill a tank up with water and then you seal it, and the water you can set it in there for 50 years and there's no going to rust appear in there. It isn't going to work. It's got to have air. So again, I thought maybe the problem was any kind of penetration, and I replaced those valves. Okay, this is getting too long for this. Let me call this section one of this, and then I'll talk about what I tried to do to fix a leak. This is Uncle Ron's stuff. This is about a water heater leak. The first part was just covering the basics of what elements are in your water heater, and talking about leaking. Leaking is a busted weld. There is a problem with the weld. And depending on how the tank was designed, in my particular case, I have a concave bottom tank, and I've confirmed that's true. And what I think is that the flue has been welded from the inside. That was one portion of the tank, the concave bottom, and this pipe welded from the inside. And then another assembly went down over the flue pipe, came down to where the concave bottom was. That was then welded from the outside, and at the top, the flue pipe was then welded from the outside. That's what I suggest how it was manufactured. It was basically, it's three pieces, the bottom, the flue, and the top. It may have been made in different ways. I doubt if it was cylinder top, stacked on top of cylinder and then welded around that way. You wouldn't want that many welds in there. But anyway, a weld is where the leak starts occurring. More welds, more leak. Less welds, less leaks. Okay, that's enough on this. Uncle Ron stuff. This has to do with basic hot water heating and leaking, and I showed you a lot of components.